Welcome to your 8th ACT Math video. As always, please set a timer for 8 minutes to work on your 5 questions. When the timer goes off, unpause this video so you can hear the discussion of the answers. Absolute values. So the main thing, absolute values, the first thing you need to remember, you need to actually get the absolute value by itself. You need to isolate that absolute value. So I'm going to add 2 to both sides, and then divide both sides by 3. Because that's how I get the absolute value by itself. Once it's by itself, if you recall, you end up taking the positive and the negative. And now you have to solve both of those independently. But you need to make sure you get both answers by remembering that you take the positive and the negative. And now it's just algebra. Add 5, divide by 2, add 5, divide by 2. And you will see that you get answer A. Our second one. So second one is going to take a lot of work because trig is really tricky and you honestly don't get too much exposure to it. So the first thing I'm going to recall is every trig function has a reciprocal. So cosecant, I want you to remember cosecant is the same as 1 over sine. Okay, they are reciprocals of each other. So the first thing I'm going to do is I'm going to write this in terms of sine. Now, the next thing that we have to do is in order to do this, we have to compare like angles. Well, right now we have opposite angles. We have theta and negative theta. So I need to figure out what does sine do if you take its opposite angle. Okay? Now, this could take quite a bit of work, but I'd say since we have our calculators, let's investigate with our calculators. Let's just experiment. If I were to take the sine of 1, let's say, so sine of 1, my calculator tells me that's about 0.0175. Well, let's investigate what happens if I take the sine of negative 1. That gives me negative 0.0175. Okay, so just for that little investigation with real numbers, doesn't it look like if I take the opposite angle, it's just giving me the opposite of the sine value? So don't be afraid. Take a moment and you can explore with real numbers if you need to do some investigations like that. But what it's implying to me is if I take the sine of my original angle, it's just going to give me the opposite answer. Okay, that's what it's implying. And there's a reason that is so important to get that. Because now I have those like angles. And now I actually have to return to this idea up here. Okay, so there's also a property that says tangent is sine over cosine. All right, however, that's not quite what we have here, is it? This is probably the one you remember, but it's not what we have. We have cosine over sine. So unfortunately, the next thing you have to remember is the reciprocal of tangent. And the reciprocal of tangent is called cotangent. So a lot of vocabulary, a lot of terms being thrown around here. But if you remember that this is cotangent, and I produced that negative. So when all is said and done here, you're going to end up getting negative cotangent. All right, let's see what's happening for our next one. So here, an electrical pole casts a shadow that is 15 feet long. If a wire connected to the top of the pole and fastened to the ground at the tip of the shadow makes 55-degree angle with the ground. So here, I'm going to draw a picture of what's happening here. So here's my pole. It is creating a 15-foot shadow. Then, when that wire is strong, it's telling me it's making a 55-degree angle with the ground, and we want to know how can we express the height. All right, so whenever you're solving one of these pictures, when you're given a triangle and you're asked to solve it, first I want to identify how are my sides related to that angle. Well, here this side is opposite, and this side is adjacent. So if you remember SOHCAHTOA, if I have opposite and adjacent, that means I'm going to be using tangent. So the tangent of my angle is the opposite over the adjacent. And if I just want to know what that height is, I want to solve it for the height, I'm going to multiply that 15 over, and I can express the height as 15 times the tangent of 55 degrees. All right, for our next one, which of the following is not equivalent to the cosine of 495 degrees? So here, the first property I want to recall with you is that seems like a really large angle, doesn't it? 495 degrees. So I want you to remember that degrees are cyclic, right? If you remember the unit circle, you just keep going around. So what I want you to recall is that angle measure is the same thing as when you subtract 360 from it. Oh, I'm sorry. So 495 degrees is exactly the same thing as 135 degrees. So that means that this cosine value will be exactly the same as that cosine value. So once we know that's the same, I'm going to scratch it off. All right, what if I do that again? What if I take the 135 degrees, I take off another 360, that's going to give me negative 225 degrees. So again, that is the exact same angle measure. Okay, you can add and subtract 360 degrees time and time again, and it's going to be the same angle. So that also means now this one we already know is the same, we can scratch it off. For the remaining ones, now I would use the calculator for these, okay? Because you can calculate the cosine of 495 degrees. My calculator gives me about 0.7071. Well, let's see which one of those doesn't give me the same value when I type it into my calculator. So now I'm going to type in negative cosine of 45 degrees, and it gives me exactly the same thing. So I'm going to scratch that off. I'm going to type in negative sine of 45 degrees, and it gives me exactly the same value. But when I type in sine of 135, it's giving me the positive of it. It's not giving me the same thing. So because it's not giving me the same value, I know that one is the different one, and that's going to be my solution. And our last problem. What is the period of the function f of x is 4 sine of 2x plus 2? All right, so the period of these functions. So if you recall, the sine function starts in the center and it cycles like that. And it completes a cycle every 2 pi. So the period of this function, how long it takes to complete a cycle, is a full 2 pi. That's for a normal sine function. But what I want you to notice is this sine function is going twice as fast. So because it's going twice as fast, that period that I have is cut in half. So of this new one, its period is only taking pi, okay? Is going twice as fast through its cycle, through its period. Let's briefly talk about what else does this tell us. This 4 is the amplitude. Amplitude controls how high or low it goes. So this one will be going 4 times as high and 4 times as low. Okay, that's what that controls. And this +2 right here would shift it up by 2. All right, so just to take into account, so you recall what each of those things do, because again, the ACT could ask any one of those things. What is the 4 doing? What is the 2x doing? And what is the 2 doing? The 4 is stretching it out, changing the amplitude. The 2x is changing the period, making the period faster. And then the +2 would just shift it upward by 2. All right, thank you for joining me for this last ACT video. And when the time comes for you to take the ACT, I wish all of you the best of luck.